In studio, we have Dan from Juggerbot 3D. Welcome to the studio down here. Why don't you give our viewers a little bit of your story, where you came from, where Juggerbot 3D came from?
Sure, yeah. Thanks for having me,
Absolutely.
by the way. So Juggerbot 3D is an OEM in the industrial 3D printing space. We manufacture large format industrial 3D printers that are pretty uniquely capable of processing a real wide variety of performance materials. So we find ourselves in a lot of really interesting niche applications where 3D printing historically has not been a very good fit. We started back in 2014. It was there was three of us. We were all pursuing our undergraduate engineering degrees at Youngstown State University, and one of our professors was very involved with America Makes, which is the national accelerator for 3D printing, for that being installed here in downtown Youngstown. So we were, I think, privy to the future of 3D printing at a time when most people were still either not in the know, really weren't familiar with 3D printing at all, or were familiar with it for prototyping purposes, which I think was a benefit to us. We all have, I think, some entrepreneurial influences in our lives. So immediately, we're thinking, how can we start a business, a manufacturing business that utilizes 3D printing? So this is like 2013-ish. And quickly found out that at that point in time, there was this huge gap between some of the industrial printers that were doing more functional printing or production, and a lot of the printers that were getting the mainstream attention, which were more so for education and DIY kind of hobbyists. So that's when we decided that we would address that gap between there and initially start off with an engineering grade printer, which has eventually evolved to be more of a all things industrial type of 3D printing.
So now you guys have been a really long tenant of the YBI building down there. Are you the longest running down there?
We're probably not the longest running, but we're up there.
Okay.
Yeah, they've been really good to us. We could not have asked for a better partner, and I'd say they serve multiple roles. They're friends. They're a lot of cases they're like evangelists for us. They are advisors to us. They make sure that we have what we need and don't mess up too bad when we're going down the wrong path.
And they're very connected, so I'm sure
connected.
Lots of opportunities come to your doorstep.
Absolutely. Yeah, definitely. Including actually America Makes being one of their portfolio companies. We're within a 20-second walk to America Makes. And being that it is the national accelerator, they have a lot of events that they host. They have a lot of projects that they have calls out for, and a lot of traffic that comes through that building for meetings or for reviews. So we've got prime real estate being kind of right across the parking lot from them.
So the general public, their exposure to 3D printing is probably pretty limited, those hobbyists that you talk about. So when you have some kind of industrial setting or manufacturing setting with 3D printers, kind of paint that picture of like who is your industry and who's your customer for these.
So we break it down if you look at kind of like a table, a lot of our applications, the low-hanging fruit is in tooling, but we've seen a significant amount of traction in end-use parts as well. So using 3D printing as the end means to produce whatever it's going to be. By industry, we've got a fair amount of business in the defense sector, in aerospace, in energy, and then outside of that, we really focus on transportation, which would be marine, so boat building, as well as like your non-automotive type of equipment.
Let me give you two examples that just blew my mind because they're such a good idea. So one was the Navy, and if they were out to sea and they broke a bolt or had some kind of like something go awry, they would have to come all the way back into harbor and restock and replace that. Now they can just print their own tooling or their own parts out there and not have to break stride from being at sea. And I'm thinking that's genius.
Yeah, that's the goal, right? Is to be able to have more of a leveraged manufacturing base. Now, again, a lot of the Navy ships we can't even really fathom how big they are and how equipped they are. They have their own machine shops. There's a lot, the stored inventory. So depending on what kind of bolt, they could put them in bad shape. But there's a lot of things that go bad, and there's a lot of purpose and I think reason behind, or I should say, incentive to be able to have this more distributed manufacturing technology that can be, whether you're out at sea or whether you're in, the Arctic Circle or in a place where you really don't have ready access and logistics support to bring in finished product from more traditional manufacturing places.
Yeah, and the second one is a company that does like robotics and automations. And when they prototype some stuff, they used to have to put CAD together, send it away, get the prototype back like 3 weeks later, and then see if it worked, if it fit, if it did its thing. And now they go and drive it right into the 3D printer, print their own prototype, and see if it fits and works. And it sped the invention time up like huge.
Absolutely. And even, I guess, from a time to market or on demand kind of manufacturing, one of our core customers, which has been a great partner to us as well, is a company called BDI Additive. And they're headquartered out, BDI, the parent company, is headquartered out of Cleveland, but their parts replication business, as they call it, is headquartered here in Youngstown. And that's the premise of their business model. They've got a huge business that's all built on being able to essentially supply distribute industrial supplies, everything from bearings to gears and sprockets. And the portfolio is now, or I should say the catalog, has expanded to include tapes and adhesives and all kinds of stuff. Well, 3D printing is something that they can use to leverage that footprint and those relationships to then be able to offer obsolete or long lead time items. And in especially with some of the largest manufacturers in the world, every hour that the plant isn't running is tens of thousands of dollars, if not more, of lost revenue. So yeah, definitely some interesting ways different philosophies on how you can now approach business.
So, and if, for our viewers that don't understand how 3D printing works, is think about it as, your basic printer prints two-dimensionally on a sheet of paper. Now, if you were to stack a ream of papers together and have some kind of computer plot out all the pixels that should be filled in, right? It does that over and over again. So I've gotten, like doing a model, I've gotten 26 hours into a project and have something go awry.
It's a bummer.
It is. It's frustrating.
Yes. We've had prints. So reliability is something we focus a lot on because, again, when somebody buys our machines, or if we're working with somebody, it's not generally tied to a bigger project where if they have a couple fails, it's going to be okay. There's going to be big problems. If it's on the production floor or if it's in the machine tool, in the machine shop, then there's a lot more criticisms over delays. And so reliability comes largely into I think first and foremost into the architecture of the machine. So the quality of the components, the actual construction of the machine itself to be repeatable time and time again. And then the control side, which is where we spend a lot of time. We've got I call it a software stack. It's basically a whole suite of calibration programs and software tools that really streamline production.
So two things, like, do you have any limitations on how big a machine could be built to accommodate?
Good question and timely. So for most of the world, we'd be considered large format. The machines we currently offer, which we call our Tradesman series, that would be considered a large format machine. It's build volume, so we can build, in theory, a part that is 3 feet by 4 feet by 4 feet. And we've printed parts that have been more than 500 pounds, so fairly large parts. Our particular technique, the type of 3D printing technology we've developed, is called fused granular fabrication. We refer to it as pellet-fed 3D printing. That technology has been around commercially since like the 2014 timeframe and started on machines that had travel distances of 10 or 20 feet by 10 feet by 8 feet. So we're medium format right now, and that's a very fast growing segment of the pellet-fed 3D printing space. And we're the technology leaders in that space in a lot of different perspectives. We'll be very quickly getting into larger machines than that, which, you'll stick around, you'll see an announcement from us here in the coming weeks.
Beautiful.
Yeah.
This episode was brought to you by Youngstown Computer, the Valley's technology company. We appreciate the loyalty and all you have shown us over the years, and it's our promise to serve all the technology needs of the Valley. Call 330-259-7278. We have both home and business services available. Everything from repair, installations, and new equipment. You can improve your Wi-Fi and have technology serve you better. Call 330-259-7278. Or you can schedule your appointment right now on youngstowncomputer.com and look for the red Book Now button.
And what kind of materials do you do now, and what do you see on the horizon?
Yeah, so our game is all focused on thermoplastics and thermoplastic composites. So we are primarily playing in a space that is using glass or carbon fiber reinforced thermoplastic materials. But we've done a lot of unfilled materials. We actually, one of the interesting things about pellet fed 3D printing is that I hate to use the word synergy, but there's a very nice fit between pellet fed 3D printing and material science and developments in both. So basically, when you have a development in one, it's a catalyst to developments in another one, and vice versa. So not only do we deal with more common fiber reinforced materials, but we've dealt with materials that have like carbon nanotubes or nanoparticle technology, and a lot of materials that are kind of pushing the sustainability play, which is both recycled materials as well as materials that are made with more like bio-friendly materials and or natural fibers.
All right, let's watch our video here.
So this is all going to change here in about 4 months, with a little help. So we do all of our manufacturing down here in Youngstown, Ohio. All the final assembly takes place in our shop, which used to be the old Vindicator building. This is the 5th building of the, of the Youngstown Business Incubators campus. And what you're seeing here is essentially packaging and incoming materials. So we are not the only tenants in this building, but I think that it's probably fair to say we're the anchor tenants. We've got most of the first floor, and essentially what you're seeing is the production side of the floor. So all these crates, that's ideally going to go. This what you're looking at down right now is a bay where they used to have the printers. This is our customers' shop where we have some of the machines, some of our tradesman series, and we'll perform some of our printing services, because a lot of times we're helping customers to be able to vet out specific materials and parts before they're ready to make a purchasing decision, kind of like their R&D side of things. But we'll be building out in part of our phase 1 expansion, a mezzanine structure. So all that packaging, all those materials are actually coming through a different side. We're just outpacing construction. Good problem to have.
Absolutely.
Right? Good problem 100%. To have. What you're seeing here, so this is actually what the thermoplastic and composite pellets look like. And I think, I don't know what usually comes to mind when people think of pellets, but traditionally, material extrusion 3D printing is in filament form. So these pellets, this is obviously one of the big reasons we're able to tap into a much wider variety of materials.
So it's like a hopper that you put the pellets in, and
correct,
and it melts them?
Everything starts with a dryer. So it's very important that when you're processing plastics, not just in 3D printing, but in any manufacturing process, that you are drying your material, because a lot of plastics will absorb moisture. Some of them, even the ones that don't absorb moisture, will collect moisture on the surface. And if you do not remove that moisture down to at least to a minimum percentage, then you'll have a lot of issues with extrusion and with processing. Sometimes if it's really bad, you'll see off-gassing. There'll be legitimate bubbles coming out of the extruder. Other times, in the worst case scenario, you won't see it. You'll end up making your part, but the bonds between each layer are very, very weak, so then the part will ultimately fail. One of the things that's maybe important to mention is that we are a material agnostic system, meaning that the folks that have our systems, they can work with whatever material supplier and whatever material they'd like to purchase, which does a couple things here. So there's been for the past decade, a debate going on in the 3D printing world between proprietary material systems or closed systems, where if you buy their system, you have to basically buy materials. It's like the Gillette business model, right?
Right.
You got to buy materials from that OEM, and that artificially inflates the price of the materials they have and really drastically reduces the number of options that their users have to choose from. So when you ask people, do you want to be stuck buying these materials, or do you want the freedom to choose? Human nature would have you say, yeah, I want the freedom to choose. I want to have control of my own destiny. And that's a big thing, except for the fact that then those folks have to develop the process parameters for all the different materials they're trying to choose from, which can kind of be tricky. Some of those software tools I mentioned make a world of difference in being able to help enable the tradespeople that will be dealing with these systems, but historically it's been kind of a challenge. The promotion of this being such an easy technology to use has really been, I think, a hindrance to further progress, because if you buy a machine and you're promised that it's going to work, and then ultimately it's a heavy paperweight, that hurts everybody else. So we really try to be on the forefront of articulating these challenges, and then obviously spend a lot of time on trying to develop solutions for them.
Yeah, even like the regular printing market, where if you buy OEM ink right from the printer manufacturer, it has a tendency to go a little bit smoother and be a little bit easier.
Yes, definitely. So very similar, good parallel there. This is a dryer. So as I mentioned, everything is, you want to make sure you're drying on materials before you start. Really important. The machine you see here is actually an older machine. So we started off in the filament, with filament technology. And they're both material extrusion, filament and pellet-based printing, except for the fact that, for one, filament has been around since the early 80s. So it's one of the original additive manufacturing technologies. And while there's a huge installation base out there, it's a very big market, very well established and very segmented. It's obviously very competitive, and there's more of that noise on what it really takes to be a good machine, who you can work with. So in 2022, early last year, we were one of, I call it like 4 or 5 big players in the fast-growing pellet-fed 3D printing space. And then within a 2-month span, our biggest competitor got purchased by 3D Systems, and our what we consider our second biggest competitor decided they're going to exit 3D printing altogether. So we got out of filament, which was the F332 you just saw, and we doubled down on pellet because we saw that we were in a really good position to take advantage of this really fast-growing segment, because ultimately we want to become the global leader and premier partner in that space.
That's beautiful.
This is the P344 here. These are actually BDI Additives machines. Again, we have a really good relationship with them. I'm very thankful for that relationship, but as this is our marketing manager, Ben, is walking you through some of the materials that we deal with would include your high temperature or aerospace grade materials, which obviously is really important. And these are some of the hardest materials to process. Big reason being, it's not just about drying and maintaining that composition, but you have to be able to artificially create an environment which those materials can be handled. So a lot of times, we don't have physical surfaces that can help control the cooling or how much heat is held within the part that's being made. It's just air. So you have to essentially create like an oven within the system. And to do that in a way that not just mitigates variance, but also creates some kind of consistent temperature throughout the whole chamber and doesn't compromise the other components of the system, is quite the challenge. We've got obviously 9 years of experience figuring that out. Right. We think we've done a pretty good job with that. But that kind of mixed in with the controls of what you're seeing here, that's a very vital combination.
Need social media management or marketing services for your business? We specialize in graphic design, logos and rebranding, commercial video production, podcast production, social media design and advertising campaigns, newsletters, radio advertising, and voiceovers. Call Youngstown Studio Marketing today, 330-259-7278, and choose option 3. Youngstown Studio Marketing, a Youngstown computer company.
Earlier this year, BDI announced their second machine, their second P344. So they've actually kind of expanded, maybe a shout out to them. They've done a really good job. They've expanded out of just doing long lead time items, and they've started to engineer some of their own parts for their customers. So a lot of large pieces, a lot of covers. And again, we've actually been able to, because of that capacity, bring in some pretty cool projects. One that's worth noting was, when's the last time you were at airport?
It's been a while.
Okay. So especially with international airports now, there's a big trend to change the whole experience for the people that are going on flights. And terminals are getting longer. There's more distance. So the people movers you see are becoming more abundant. And they're not just golf carts anymore. They're electric. There's connectivity involved. Some of them are going towards the autonomous route. One of those manufacturers is a customer of ours, and we printed not just one prototype, but a whole basically arsenal of the body kits for the incomplete body for people movers last year on those machines, which was really a fun project to do. So this is the basement here of Tech Block Building 5. We're going to, I think, walk back up. This is our original printing press. I'm just kidding. That's a printing press from the Vindicator back in the day. A little testament to what was and what is now. Funny side story. Zach and I, so Zach's the other co-founder, he's our president. We both delivered papers for the Vindicator.
Really?
So when we were kids, we were each here at some point in time, either picking papers up or dropping checks off or whatever have you. And now we have a business here that makes three-dimensional things. So nice little circle of life.
And it looks a little different, I bet.
A little bit, yeah. That is, so I mentioned tooling being a big piece of our business. And kind of tooling is a vague term that encompasses a lot of different things. For us, and what's unique about our technology is that we can print parts in a way using materials that lend themselves to production tooling, true production tooling. So this is an example of a forming die. This is just the sample piece. An actual one was printed down at Oak Ridge National Labs, who is a technology partner of ours, a male and a female side, where it's printed, and then there's some post-processing on the interfacing surface, which is why you see part of that smooth and part of it rough. The rough piece is as printed. The smooth part is after, I think they put it on a router, and then they do a wet sanding process. But they use these to stamp the hood of a Shelby GT Cobra.
Oh, no kidding.
Yeah, so pretty cool. More tooling. This is a composite tool, an example of a composite tool for the aerospace industry, for a carbon fiber baffle. And then what's kind of, those are fun prints. We have a couple engineers that are very creative and have come up with a couple designs for both burn-in, so basically the initial test and calibration. But you'd be surprised how much traction and how much attention 3D printing, specifically our 3D printing, is getting from the construction industry for furniture as well as infrastructure. Right now you see a lot of things that are just piled where we can place them because we need the space for production. Again, good problem to have.
Yes.
And also some of these things will be moving either upstairs or be moving all together. So like that gray machine you see back there, that is actually our Gen 1 Tradesman Series P344. We built that in 2019 and officially launched that line in March of 2020, which was a great time to launch a product line.
Heck yeah. Walking
into the floor here. We just onboarded our 10th employee, and with a little luck here, we're hoping to have the 11th employee on board by the end of the month. But we really have a pretty aggressive growth plan. It's all doable. It's all comes with pipeline. But next year we should probably be around 18 to 20 people full time.
Nice.
Yeah.
Beautiful.
So you're walking through one of the work cells right now. If I'm seeing this correctly, this is probably the cell 1, which is where a lot of the electrical assembly takes place. And then that's the view to the side in cell 2 and cell 3, which is where the frame starts coming together. It's surprising. I think when people walk through here, they don't realize that especially when they see our piece of equipment, if they know what it looks like before they go into it, they don't realize that it all gets made there. But our team's done a really good job. And our background is industrial engineering. We're lucky to have a team that I think is both, they can do the computer work, but they can also get their hands dirty and dig into it. And it's been, I'd say a blessing because there's not that much space in here. It's really amazing what they've been able to do. That's the chamber I mentioned, right? You can't really, you can kind of see it here. The side walls and the back walls, that's all stainless steel. It's insulated. And we're circulating heat to that back wall to get up to 95 degrees Celsius pretty consistently throughout the entire chamber. So as a point of reference, I believe it's 40 degrees Celsius is technically room temperature. So it gets pretty hot in there. Here's a look at the interface. And right now, what you're seeing is the configuration for our material card, which is a recent launch that we did earlier this year. That is the culmination of that software stack I mentioned. We've got a couple really cool enabling tools or technology we've developed that really kind of flip the way tool paths are generated on its head. So historically, especially on a material agnostic printer, I like to think of it like tool paths being generated from the ground up. Now, the PelletFed 3D printing process, there are thousands of variables that you have to control. And the process is dynamic by nature. So things will change as a print is going on or as you either use a different material or use a different nozzle size, but they're not going to change necessarily in linear correlation to each other. So in order for somebody to have a full parameter set or data set for a specific material, machine configuration combo, you're talking about thousands and thousands of different scenarios that they have to play through and hone in on each one of those parameters. You're talking extrusion speeds, temperatures, bed temperatures, acceleration and deceleration, etc. So instead of having to do that ground up type of work that is obviously prohibitive to this being a viable manufacturing process, our team has developed what I like to think of as a top-down approach called bead area mode. So after you've identified your core printing, your processing windows, like this is the minimum and maximum these things can be, we have made it so that the operator can dictate just the fundamental elements of a print, which is your layer height and your bead width, and then everything else is driven from that. Dry air dryers, more incoming material. Actually, everything you see here is gone already. Kind of again, good problem to have.
Exactly.
But
doesn't spend time there.
Yeah. It was kind of scary too. We decided to get out of what we called build to order. So we would we would start the production process after we had an order from a customer. But especially with where the manufacturing landscape was coming out of COVID, prices were really volatile. Lead times were all over the chart, and sometimes we were getting lead times that would put us out, 9-10 months. So we made the decision that we were going to invest in stock, and with a firm belief that there was need there, that we had the right tools for the job. And again, we have. I'm proud to say that we have sold out of all of our 2023 stock. Some of this is the 2023 stock. Some of it is the 2024 because we ended up pulling that order ahead and started that just this past week. Now, I mentioned that we're going to have a phase 1 expansion, which will build that mezzanine structure out and will take up most of the second floor. So we'll have roughly 50 or 60% of the building. We'll have a phase 2 expansion plan that will take us out of that building, more than likely because of the larger system and because of, just the growing demands. We'll probably embark on that late 2024, early 2025. Now you're just seeing the pellet extrusion process in place. This either is a really small part or a really big nozzle, or it's slowed down. Because now we're pumping out a lot of material, and our extruders are capable of extruding more than 300 times faster than traditional 3D printing. But sometimes, depending on what the nozzle configuration is or the part size, the travel distance of the machine itself is pretty impressive. It can fly around.
Well, thank you for letting us peer into your world
Absolutely.
For today. If anybody wants to look in and learn more about your company, where can they find you?
You can go to our website. We're at www.juggerbot3d.com. That's Juggerbot 3d.com. You can follow us on LinkedIn, and you can always reach out to us at 330-301-2190, or you can reach out to me at Dan@Juggerbot3D.
Well, best of luck to you in your expansion and growth, brother.
Thank you very much. Thanks for having me.